Will SARS-CoV-2, the species of virus that causes COVID-19, ever go extinct? And what happens when two variants clash? It's spring 2021. The Alpha variant of the coronavirus has spread rapidly, becoming the dominant variant worldwide. But another, more transmissible variant is about to appear: Delta. What happens when two variants clash? Let's do a thought experiment. Suppose that the variants reach a hypothetical, isolated city of 1 million people who are completely susceptible to both viruses on the same day. When a person here is infected with Alpha, they transmit it to, on average, 5 close contacts. Then, begin to feel sick and immediately isolate themselves for the rest of the simulation. The same thing happens with Delta, except that an infected person transmits it to, on average, 7.5 close contacts. What would you guess happens next? After 6 days, Alpha will have infected 15,625 people. Delta will have infected more than 10 times as many. Just 20 hours later, Delta will have infected the rest of the population, all before Alpha could infect 6% of it. With no one left to infect, Alpha dies out. This model is drastically simplified, but it accurately reflects one thing that did happen in real life. When both variants competed, Delta drove Alpha towards extinction in a matter of weeks. Viruses are wildly successful organisms. There are about 100 million times as many virus particles on Earth as there are stars in the observable universe. Even so, viruses can and do go extinct. There are 3 main ways that can happen. First, a virus could run out of hosts. This might have happened in early 2020 to a flu lineage known as B. Yamagata. When much of the world shut down, social distanced, and wore masks to slow the spread of COVID-19, that dramatically reduced the number of hosts available for B. Yamagata to infect. It'll take a few more flu seasons to know for sure if it's truly extinct or just hiding out in an animal reservoir. Many viruses, as part of their life cycle, cause diseases severe enough to kill their hosts. This can be a problem because if a virus kills all its hosts, it could, in theory, run out of hosts to infect and go extinct. This almost happened back in 1950s Australia. At the time, Australia was overrun by the European rabbit, an invasive species. So, in an attempt to control the population, scientists released a virus called myxoma, which had been previously shown to be almost 100% lethal to European rabbits. During the initial outbreak, as planned, tens, perhaps hundreds of millions of European rabbits died. But as the virus spread, it evolved a series of mutations that happened to make it less deadly, killing rabbits more slowly and killing fewer rabbits overall. With more infected hosts hopping around, this strain of the virus was more likely to spread than its deadlier cousin. And of course, rabbits evolved too to mount better immune responses. Overall, instead of killing every single rabbit, the virus evolved. The rabbit population bounced back, and both survived. The second way a virus could go extinct is if humans fight back with an effective vaccine and win. Vaccination campaigns have driven 2 viruses essentially to extinction since vaccines were invented in the 1800s: smallpox and rinderpest, which kills cattle. More on vaccination later. The third way a virus can go extinct is if it's outcompeted by another virus or strain, like we saw earlier with Delta and Alpha. By the way, viruses don't always compete with each other. A viral species can carve out its own distinct niche. For example, influenza infects your respiratory tract, and norovirus infects cells in your intestine, so both of these viruses can coexist. A virus's ecological niche can be tiny. Hepatitis B and hepatitis C viruses can infect the same cell. Hep B occupies the nucleus, and Hep C occupies the cytoplasm. In fact, epidemiologists estimate that 2 to 10% of people with Hep C are also infected with Hep B. So, will SARS-CoV-2, the species of virus that causes COVID-19, ever go extinct? Variants within the species will continue to arise. Those variants might drive prior ones to extinction, or not. Regardless of how the variants compete or don't, The species itself, to which all the variants belong, is pretty firmly established among humans. If we manage to vaccinate enough people, could we drive SARS-CoV-2 to extinction? Our vaccination campaign against smallpox worked because the vaccine was highly protective against infection, and smallpox had no close animal reservoir in which it could hide. But SARS-CoV-2 can hide out in animals, and our current vaccines, while they provide excellent protection against severe illness and death, don't prevent all infections. So conceivably, there are two ways that SARS-CoV-2, the entire species, could go extinct. A cataclysmic disaster could kill us all, or we could invent a universal vaccine that prevents all SARS-CoV-2 infections, those caused by all the variants that currently exist and those that don't. Let's work toward that second option.